Welcome to this module on outside and inside views. And this module is going to provide you with a practical method to integrate research data with your own experiences. And in the module titled Can It Be Improved?, I presented research showing that probability training can improve decision-making performance. And I've highlighted the rows in yellow here, showing that the participants who received probability training improved their scores in some cases by up to 50%. And what's interesting about the probability training in this study was that it can reduce two of the decision-making errors that risk impacting us as sports practitioners. One of the errors is called overfitting, and this is where we put too much weight on information from research and we anchor our decisions exclusively to what research says. And a classic example of this would be anchoring players to specific ratios of acute to chronic training load and then blanket applying this to all athletes and all the sports that we work with, which is obviously a decision error in hindsight. And the second error would be the opposite, and this would be underfitting. And this is where we put too much weight on our own personal experiences and we ignore useful patterns and trends that research might tell us and indicate around what would make our decision more effective. Practitioners working in sport tend to be overconfident, and overconfidence causes us to put more value and more weight on our own experiences. So in sport, we need a decision-making strategy designed specifically to mitigate overconfidence. To begin any decision-making process, we should always begin by increasing our situational awareness by asking, do I have to make this decision quickly, or do I have sufficient time for some analysis? And the outside to inside view is a systems to analytical decision-making process, so we should be using it when we have sufficient time to do some analysis and in complex high-stakes decisions. In step 2, we're essentially trying to answer the question, what typically happens in situations like this? And to do this, we want to use a wide range of different sources of information, just like super forecasters do. So we don't want to be tribal and only look for information that confirms our pre-existing beliefs. We want to look for disconfirming information, and we want to consider the widest range of information that we can. And this can be from research papers, it could be from our own longer term data, it could be from statistics online. And if there isn't statistics or evidence for this exact situation, you might want to find some comparative information, or you might want to do your own research and try to come up with a probability for what the outcome is going to be. And the reason that we're doing this is because we're going to put a numerical confidence on our decision for what we think is most likely to happen in similar situations, regardless of the specific details. For example, we might be trying to find data on how long does it take on average for athletes to return from this type of injury. We might be trying to find data on the expected change in a fitness parameter over the same period of time as we have for a pre-season, or it might be from our own internal data around how many years does it take for an athlete with this profile to progress through to the senior team. Now in step 3, we want to answer, in what ways is our current situation different from the typical situation? For example, are we constrained because of access to facilities or time for training or access to quality staff? And perhaps we want to consider the quality of our inside evidence. Did we collect this data under robust and repeatable procedures, or does our data have holes in it which would decrease our certainty and confidence in our data? And importantly, what clues does our experience or similar situations tell us about what's likely to happen? Simply, the outside to inside view shifts us to start thinking about our decisions as predictions and start quantifying our confidence using percentages. So we start by taking our prior predictions using a large sample of data from research or statistics, and we put an initial probability on what we expect to happen. And then we adjust this number up or down a little bit based on our experiences and the uniqueness of this situation. And in this world of AI and big data, it might come as a surprise, but there's very strong research showing that a combined human and statistical approach produces more accurate decisions compared to either humans or statistical models alone, particularly for complex, unpredictable situations like we find in sport. So this hybrid approach of using data first to set a prior prediction and then adjusting this with our own experiences and the uniqueness of the situation that we're in is definitely the way to go to improve your decision making. Okay, there's three take-home messages to improve your decision making. First, if we initiate our decision making using the situational information and our own experiences, we're at significant risk of underweighting the much larger body of information of what typically happens in the outside world. Similarly, if we stick rigidly to what the research says, we're going to underweight the uniqueness of our own current situation. So we need a combination of both. Secondly, we want to think about our decisions as predictions and quantify the confidence using numerical percentages. And this is really useful for feedback, and it can help us to score our decisions using a Brier score. And finally, AI and big data are useful tools, but at the moment they're based on historical data and they don't capture the nuances in our current situations. So we should start practicing using the outside to inside view more often, particularly for high stakes decisions, because this can improve our decision making performance by up to 50%.